And now in this lecture we'll answer on two questions. In the first question we'll find out the blue area, and in the second question we'll find out the radius of this circle that blocks triangle ABC. So we start with the first question. In the drawing we have this circle, and we know that AB is the diameter of this circle. Inside this circle we have triangle ABC. Actually, triangle ABC is inscribed by this circle, the big circle, and inside triangle ABC there is a small circle. Actually, the small circle is inscribed by triangle ABC, and we know that the radius of the big circle equals to 13 units. The radius of the small circle equals to 4 units. And we want to find out the radius of the big circle. And we want to find out the area, the blue area. Okay, the radius of the big circle equals to 13 units. The radius of the small circle equals to 4 units. AB is the diameter of the big circle, and we want to find out the blue area. So first of all, we will define the center of the small circle as point O. We will define the point of tendency of tangent CB with this small circle as M. We will define the point of tendency of tangent AC with this small circle as N. And we will define the point of tendency of tangent AB with this small circle as L. And we'll join points O and M together by a straight line. Line segment OM starts from the center of the small circle, that is to say from point O, and ends at point M, that is a point on the small circle itself. This is exactly the definition of a radius. That is to say, line segment OM is the radius of the small circle, so we define it as R, small r, and it is equal to 4 units according to what is given us in the question. And we actually have rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I repeat again, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here, the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent CB with this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. In the next step we'll join points O and M together by a straight line. Again, point O is the center of the small circle. Point N is a point on the circle itself. This is exactly the definition of a radius. That is to say, NO is the radius of the small circle that is equal to 4 units. So here we have the radius ON that is drawn to the point of tendency, that is to say it is drawn to point N, That is the point of tendency of tangent AC with this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NO. So AC is perpendicular to NO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. And we also have a rule that states that peripheral angle that rests on the diameter of a circle equals to 90 degrees. So here we have peripheral angle ACB. This angle rests on side AB, that is the diameter of this circle. Therefore, according to the rule that I mentioned, peripheral angle ACB must be equal to 90 degrees. So angle ACB, this angle also equals to 90 degrees. It is a right angle. So actually in quadrilateral ONCM, this small quadrilateral, we have 1, 2, 3 right angles. Again, 1, 2, 3 right angles. So I'll write it down. In quadrilateral ONCM, we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, this is actually angle MON. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we will subtract from this equation 270 degrees, and we will get that the missing angle MON equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. Okay? So I found out that the missing angle here, angle MON, equals to 90 degrees. So actually, I found out that in quadrilateral MONC, we have 4 right angles. And any quadrilateral that, that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral ONCM as a rectangle. Quadrilateral ONCM is a rectangle. Okay. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of a rectangle NOCM, they are equal to each other. It means that NO equals to CM. NO equals to CM, according to the rule that the opposite sides of a rectangle are equal to each other. NO equals to CM. Okay? But we have already found out that NO equals to 4 units. This is the radius of the small circle. So I can write here that NO equals to 4 units. And from this equation, 4 equals to NO equals to CM, we will derive that CM is also equals to 4 units. Okay? So I can write here that CM equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that OM equals to NC. OM equals to NC. But we've already found out that OM equals to 4 units. It is the radius of the small circle. So we can write here that OM equals to 4 units. And from this equation 4 equals to OM equals to NC, we will derive that NC is also equals to 4 units. NC is also equals to 4 units. So we can write down here that NC equals to 4 units. So actually we found out that all the sides of quadrilateral NOCM, they are equal to each other, they are equal to 4 units. Therefore, quadrilateral NOMC is not a rectangle but a square. Okay? So in the next step, we will define side AC of triangle ABC as A. So here, side AC equals to A according to our definition. We will define side BC of triangle ABC as B. Here, side BC of triangle ABC equals to B according to our definition, and we will define side AB of triangle ABC as C. So here side AB of triangle ABC equals to C units according to our definition. So what is the length of line segment AN? Here it is very easy to see from the drawing that AN, line segment AN equals to CA minus NC. CA minus NC equals to AN. So actually AN equals to CA, that is A according to our definition, minus NC. NC equals to 4 units according to what we have already found out. So in conclusion, we found out that line segment AN equals to A minus 4. Line segment AN equals to A minus 4 units. Likewise, we find out the length of line segment MB. The length of line segment MB, it is very easy to see from the drawing that MB equals to CB minus CM. CB minus CM equals to MB. Okay, I'll repeat again. MB equals to CB minus CM. So MB equals to CB, CB equals to B units according to our definition, minus CM. We already found out that CM equals to 4 units. So in conclusion, we found out that the length of line segment MB equals to B minus 4 units. It is equal to B minus 4 units. So we found out that MB equals to B minus 4 units and AN equals to A minus 4 units. In the next step, I will present to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. I repeat again, the lengths of two tangents from a common external point to a circle are equal. So we'll focus on the common external point, point A. Point A is the common external point in relation to the small circle, because it is not located inside the circle, nor on the circle, on the small circle, but it is located outside the small circle. Therefore, it is common external point. From the common external point, point A, we have two tangents to the small circle. We have tangent AL, and we have also tangent AN. And according to rule number 2, the lengths of those two tangents must be equal to each other. So AL equals to AN according to rule number 2. Okay? But we've already found out that AN equals to A minus 4. So we can write here that AN equals to A minus 4. And from this equation, AL equals to AN equals to A minus 4, we will derive that AL is also equals to A minus 4. Okay, AL is also equals to A minus 4. The next step we will focus on the common external point, point B. From the common external point, point B, we have two tangents to this small circle. Tangent BL and tangent BM. And according to rule number 2, those two tangents are equal to each other in their lengths. So here we can write down that tangent BL equals to tangent VM according to rule number 2. Okay? But we already found out that BM equals to B minus 4. So we can write here that BM equals to B minus 4. And from this equation, BL equals to BM equals to B minus 4, we will derive that BL is also equals to B minus 4. Bn equals to B minus 4. Here Bn equals to B minus 4. So in conclusion, we found out that 9 segment AN equals to A minus 4 and 9 segment BL equals to B minus 4. Okay, and AB is the diameter of the circle that is also equals to C. So AB is the diameter of a circle, it is twice as long as the radius. So if the radius of this circle equals to capital R, then AB must be equal to 2 times capital R. But it is given us the question that the radius of the big circle equals to 13 units. Therefore, the diameter of the circle will be equal to 2 times 13, that is 26 units. Okay? So AB equals to 26 units. So from one side, AB equals to 26 units. But from the other side, AB equals to AL plus LB. AL plus LB. Repeat again, AB, it is equal to 26 units equals to AL plus LB. Okay, so here, so 26 equals to AL, AL equals to A minus 4, so we substitute AL by A minus 4, plus LB. LB equals to B minus 4, so we substitute LB by B minus 4. So in conclusion, we found out that AB that is equal to 26 equals to A minus 4 plus B minus 4. That is to say, 26 equals to A plus B minus 4 plus minus 4 is minus 8. So we found out that 26 equals to A plus B minus 8. Here we relate to this equation number 1, 8. And we get that according to equation number 1, A plus B equals to 26 plus 8 is 34. So here we will square this equation number 1. So here we'll get that A plus B squared equals to 34 squared. So here, according to equation number 1, we found out that A plus B squared equals to 34 squared. 34 squared is 1156. So here we'll open the brackets on this side of equation number 1 and we'll get that A plus B squared according to equation number 1 equals to A squared plus B squared plus put 2 times AB, and it is equal to 1156. So this is equation number 1. In the next step we will focus on the right triangle, triangle ABC. Triangle ABC is the right triangle because of the fact that angle ACB equals to 90 degrees. In the right triangle, triangle ABC, by PT is the relation for Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here the hypotenuse is AB, therefore the square of the hypotenuse is AB squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AC squared plus CB squared. I'll repeat again, in the right triangle, triangle ABC, according to the Pythagoras theorem, we'll get that AB squared equals to AC squared plus CB squared. According to our definition, AB equals to C, therefore AB squared is C squared, and it will be equal to AC squared. AC equals to A, therefore AC squared is A squared plus CB squared. CB equals to B according to our definition, therefore CB squared is B squared. So in conclusion, we found out that according to equation number 2, C squared equals to A squared plus B squared. We know that C is equals to AB, that is the diameter of the big circle, that is equal to 26 units. So we substitute C by 26. If C equals to 26, it means that C squared will be equal to 26 squared and it is equal to a squared plus b squared. 26 squared is equal to 676, so we write it down that a squared plus b squared equals to 676. So according to equation number 2, we found out that a squared plus b squared equals to 676. And because of the fact that a squared plus b squared equals to 676, it means that we can substitute a squared plus b squared in this equation, equation number 1, by 676. So we'll do it now, and we get that according to equation number 1, a squared plus b squared, here it is 676, plus 2 times AB equals to 1156. Here we'll subtract 676 from this equation, equation number 1, and we'll get that according to equation number 1, two times AB equals to 1156 minus 676 is 480. So according to equation number 1, 2 times AB equals to 480. Here we'll divide equation number 1 by 2, and we'll get that according to equation number 1, AB equals to 480 over 2 is 240. AB equals to 240. Here we'll divide equation number 1 by 2, and we'll get that AB over 2 equals to 120. According to equation number 1, AB over 2 equals to 120. But what is the area of the blue shape? It is very easy to see from the drawing that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. I'll repeat again. The area of the blue shape equals to the area of triangle ABC minus the area of the small circle. So actually the area of the blue shape equals to the area of triangle ABC. What is the area of triangle ABC? The area of triangle ABC equals to the base of the triangle, that is AC, times the height to the base, that is CB, over 2. I'll repeat again, the area of triangle ABC equals to the base, that is AC, times the height to the base, that is CB, over 2, minus the area of the small circle, that is equals to pi r squared. Pi r squared, r, and r is the radius of the small circle. So the area of the blue shape will be equal to the area of triangle ABC. The area of triangle ABC equals to AC. AC equals to A, according to our definition, times CB. CB equals to B, according to our definition, over 2. So it is A times B over 2. The area of triangle ABC equals to A times B over 2 minus pi r squared. R equals to 4 units. So r squared is 4 squared, that is 16. So the area of the small circle equals to 16 pi. So in conclusion, we found out that the area of the blue shape equals to AB over 2 minus 16 pi. So the area of the blue shape equals to AB over 2. Here AB over 2 is 120 minus 16 pi. So in conclusion, we found out that the area of the blue shape equals to 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. Okay? I'll repeat again, the area of the blue shape equals to either 120 minus 16 pi square units, or in terms of numbers, is equal to 69.73 square units. Okay? The area of this blue shape equals to either 120 minus 16 pi, or in terms of numbers, it is equal to 69.73 square units. So we finished with the first question. In the next step, I will present to you the second question. And we will solve the second question in 3 different methods. So here in the drawing, we have this circle. Inside this circle, we have a triangle ABC. Actually, triangle ABC is inscribed by this circle. We know that the area of triangle ABC equals to 9 square units. We also know that side AB of triangle ABC equals to 5 units in its length. Side BC of triangle ABC equals to 6 units in its length, and we want to find out the area and the radius of this circle that blocks triangle ABC, or triangle ABC is inscribed by this circle, and we want to find out the area of this circle. Okay, so first of all, we will do a construction from point A. We will draw perpendicular on BC. So here, this angle equals to 90 degrees according to our construction, and this angle also will be equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and BC as D. So we actually know that the area of triangle ABC equals to 9 square units. And the area of any triangle is equal to the base of the triangle times the height over 2. The base of triangle ABC is BC times the height to the base is AD, because AD creates 90 degrees with the base. So it is times AD over 2. I'll repeat again. the area of triangle ABC equals to the base BC times the height AD over 2. So according to equation number 1, we got that 9 equals to BC equals to 6 units, according to what is given us in the question, times AD over 2. Here 6 over 2 is 3, so in conclusion we found out that 9 equals to 3 times AD. Here we will divide this equation number 1 by 3, and we'll get that AD equals to 9 over 3 is 3. AD equals to 3 units. So we found out that here AD equals to 3 units. In the next step, we will focus on the right triangle, triangle ABD. On the right triangle, triangle ABD, by PT is the evaluation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, therefore the square of the hypotenuse is AB squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AD squared plus BD squared. I repeat again. In the right triangle, triangle ABD, according to the Pythagoras theorem, we get that AB squared equals to AD squared plus BD squared. AB equals to 5, so AB squared is 5 squared, that is 25, and it is equal to AD squared. AD equals to 3, so AD squared is 3 squared, that is 9, plus BD squared. So in conclusion, we found out that according to equation number 2, 25 equals to 9 plus BD squared. Here we subtract 9 from this equation, equation number 2, and we get that according to equation number 2, 25 minus 9 is 16, equals to BD squared. Here we take a root out of this equation, equation number 2, and we get that BD equals to the square root of 16, that is 4. We found out that BD equals to 4 units, so we can write down here that BD equals to 4 units. Okay, in the next step we find out the length of line segment DC. It is very easy to see from the drawing that DC equals to BC minus BD. BC minus BD equals to DC. So DC equals to BC 6 units according to what is given as the question, minus BD, we just right now found out that BD equals to 4 units. So in conclusion, DC equals to 6 minus 4, that is 2. DC equals to 2 units. So can I write down here that DC equals to 2 units. In the next step, we'll focus on the right triangle, triangle ADC. On the right triangle, triangle ADC, by PT is evaluation for Pythagoras theorem. We'll get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, therefore the square of the hypotenuse is AC squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AD squared plus DC squared. I repeat again. In the right triangle, triangle ADC, according to the Pythagoras theorem, AC squared equals to AD squared plus DC squared. So AC squared equals to AD squared. AD equals to 3, so AD squared is 3 squared, that is 9, plus DC squared. DC equals to 2, so DC squared is 2 squared, that is 4. So in conclusion, we found out that AC squared equals to 9 plus 4, that is 13. Here we take a root out of this equation, and we get that AC, the missing hypotenuse, equals to the square root of 13 units. AC equals to the square root of 13 units, so we can write here in the drawing that AC equals to the square root of 13 units. Okay. In the next step, we define the center of this circle as point O. Here, this is the center of this circle, and we will join points A and O together by a straight line. And then we will extend line segment AO until it touches the circle. And we define the touching point of the extended AO in the circle as point E. Actually, line segment AE or chord AE passes through the center of this circle, that is point O. Therefore, it must be the diameter of this circle. So AE is the diameter of the circle. So if the radius of this circle equals to R, it means that the diameter of this circle, AE, will be equal to 2R. 2 times capital R, of course. Okay. In the next step, we will join points B and E together by a straight line. Here, angle ABE, this angle ABE, rests on line segment AE, and AE is the diameter of this circle. That is to say, angle ABE rests on the diameter of this circle. And any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. For that reason, angle ABE equals to 90 degrees. Okay? Angle AB equals to 90 degrees. And we have also another rule according to the following rule. Any if two peripheral angles rest on the same chord, they are equal to each other. Okay, if you focus on chord AB, then on chord AB, those two peripheral angles rest both on chord AB. Okay, angle ACB rests on chord AB, and angle AEB also rests on chord AB. And according to the rule that peripheral angles that rest on the same chord are equal to each other, we will get that angle ACB equals to angle AEB. Angle ACB equals to angle AEB. Those two peripheral angles, ACB and AB, rest on the same chord, that is to say chord AB, therefore they are equal to each other. So if we define angle AEB as theta, here angle AEB equals to theta according to our definition. From this equation, angle ACB equals to angle AEB equals to theta, we will derive that angle ACB is also equals to theta. Here, angle ACB is also equals to theta. In the next step, we will prove that those two right triangles are similar to each other. That is to say, we will prove that the right green triangle, triangle ABE, is similar to the right green triangle, triangle ADC. But before that, if we focus on the right triangle ABE, we know that this angle equals to 90 degrees. This angle equal to theta. So this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this triangle to 180 degrees. This angle must be equal to 90 degrees minus theta, because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees equals to 180 degrees. For the same reason, exactly, this angle also must be equal to 90 degrees minus theta. So, in the next step, we'll prove that those two right green triangles are similar to each other. So, actually, we'll prove that triangle AEB is similar to this triangle, triangle ADC. So why those two white green triangles are similar to each other? So first of all, we know that those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So here angle ABE equals to angle ADC, and both angles are equal to 90 degrees. I'll repeat again. Angle AB equals to angle ADC, and both angles are equal to 90 degrees. In addition, those two angles, they are both equal to theta, therefore they are equal to each other. So angle AEB equals to angle ACD, and they are both equal to theta. Therefore, they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So here, this angle BAE is equal to this angle, that is angle DAC, and they are both equal to 90 degrees, therefore they are equal to each other. I'll repeat again. Angle BAE equals to angle DAC, they are both equal to 90 degrees minus theta. So we actually proved that all the angles of triangle AEB are equal to the angles of triangle ADC. Therefore, we proved that the triangle AEB is similar, this is the sign of similar, to triangle ADC according to angle similarity rule. And from the fact that those two right great triangles are similar to each other, we will conclude that the following equation is true. We conclude that AB over AD equals to AE over AC. I'll repeat again. AB over AD equals to AE over AC. So here AE equals to 5 units, AD equals to 3 units, AE is the diameter of the circle, that is to say it is equal to 2R. R is the variable that we are looking for. This question, and AC equals to square root of 13 units. So in conclusion, we found out that 5 over 3 equals to 2R over square root of 13 units. Here we will multiply this equation by square root of 13, and we will get that 5 times square root of 13 over 3 equals to 2R. Here we divide this equation number 3 by 2, and we get that according to equation number 3, the radius of the circle that we are looking for, it is equal to 5 times square root of 13 over 2 times 3 is 6. So the radius of this circle equals to either 5 times square root of 13 over 6 units, or in terms of numbers, it is a little bit greater than 3 units. It is 3.00, and it is numbered, it is not all the digits are 0, so it is a little bit, it is greater than 3 units. Okay, so we finished with the first method. The next step, I will present to you how to find out the radius of this circle according to the second method. In the second method, we use all the things that we already found out in the first method. So here from point A, we draw perpendicular on BC. This is the touching point of the perpendicular from point A, and the BC is D. So this angle equals to 90 degrees. And this angle will be also equal to 90 degrees according to our construction. We've already found out in the first method that AD equals to 3 units. And we also found out that DC equals to 2 units. And DB equals to 4 units. In the next step, we will extend side AD by a straight line until it touches the circle. At this point, we define the touching point of the extended line segment AD in the circle as point E. In the next step, I present to you rule number 1 that I've already mentioned in the past. According to rule number 1, if we have this circle, and we have, this is rule number 1. Here we have chord AB. This is chord AB. That intersects with chord CD. This is chord CD at point O. So if chord AB intersects with chord CD at point O, then the following equation is true, that AO times OB equals to CO times OD. I repeat again, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Actually, you can implement rule number 1 in our drawing. Why? Because in our drawing we have this circle, and inside this circle we have chord AE that intersects with chord BC at point D. Therefore, according to rule number 1, we will get that BD times DC equals to AD times DE. Repeat again, according to rule number 1, BD times DC equals to AD times DE. So BD equals to 4 units, DC equals to 2 units, AD equals to 3 units, and DE is the missing line segment. So in conclusion, we found out that 4 times 2 equals to 3DA. 4 times 2 is 8. That is equal to 3 times DE. Here we divide this equation by 3 and we get that the missing line segment DE equals to 8 over 3 units. So here we can write down that DE equals to 8 over 3 units. In the next step I will present to you rule number 2, and we will implement rule number 2 in our drawing. According to rule number 2, if we have this circle, and they're called AB. This is called AB. The intersects with called CD. This is called CD. It's 90 degrees. So at the intersection point, they create 90 degrees with each other. Okay? I repeat again, if chord AB intersects with chord CD at 90 degrees, we define the intersection point as point O. The length of line segment AO is equal to A units. OB equals to B units in its length. CO equals to C units in its length. And OD equals to D units in its length. Then the following equation is true. The 4 times R square, R is the radius of this circle that contains the 2 chords. 4 times A square equals to A square plus B square plus C square plus D square. So actually we can implement rule number 2 in our drawing, because in our drawing we have chord BC that intersects with chord AE at 90 degrees. Here, those two angles are equal to 90 degrees, but this angle, it is also equals to 90 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. According to the same rule, this angle must be also equal to 90 degrees. Okay, so all the requirements of rule number 2 are satisfied. Therefore, all the requirements of rule number 2 are met. Therefore, we can implement rule number 2 in our drawing. And according to rule number 2, we get that 4 times R square equals to BD square plus DC square plus AD square plus DE square. I repeat again, according to rule number 2, we get that in our drawing, the following equation is true because of the fact that chord AE intersects with chord BC at 90 degrees, then the following equation is true according to rule number 2. 4 times AB equals to BD square plus DC square plus AD square plus DE square. That is to say, 4R square equals to BD square. BD equals to 4 units, therefore BD square is 4 squared, that is 16, plus DC squared. DC equals to 2, so DC squared is 2 squared, that is 4, plus AD squared. AD equals to 3 units, so AD squared is 3 squared, that is 9, plus DE squared. DE equals to 8 over 3, so D squared is 8 over 3 squared, that is to say it is 8 squared, that is 64, over 3 squared, that is 9. So in conclusion, we found out that 4R squared equals to 16 plus 4 is 20, and 20 plus 9 is 29, plus 64 over 9. Here we will multiply 29 by 9, and then we will divide it by 9 in order to overcome factor with this expression, and we get that 29 times 9 is 261, plus 64 over 9. 261 plus 64 is 325 over 9. So in conclusion, we found out that 4r squared equals to 325 over 9. Here we will divide this equation by 4 and we get that r squared equals to 325 over 9 times 4 is 36. We substitute 325 by 25 times 13 because 25 times 13 equals to 325 over 36. Here we take a root out of this equation and we get that r equals to the square root of 25 is 5 and the square root of 36 is 6 over square root of 13 times square root of 13. So the radius of this circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers it is a little bit greater than 3 units. Okay, so we finished with the second method. In the next step I will present to you how to find out the radius of this circle that blocks triangle ABC according to the third method. Okay. In the third method we define angle ABC as theta, and we actually have a special formula for the area of any triangle. So here, if we have triangle ABC, that could be any triangle. This is triangle ABC. The angle between side AB and side AC is theta. The length of side AB is A, and side AC equals to B units in its length. Then according to the new formula, the area of this triangle ABC, would be equal to A times B times sinus theta over 2. Okay, we'll use this formula in order to find out here the value of sinus theta in this triangle. So according to this formula, the area of this triangle ABC, we know that the area equals to 9 square units, so we can write here 9 equals to 5 times 6 times sinus theta over 2. So actually we get that according to equation number 1, 9 equals to 5 times 6 is 15, and 5 times 6 is 30, and 30 over 2 is 15. So we found out that 9 equals to 15 times sinus theta. Here we divide this equation number 1 by 3, and we get that 15 over 3 is 5, so here we have 5 sinus theta. That is equal to 9 over 3 is 3. Here we divide this equation number 1 by 5, and we get that according to equation number 1, sinus theta equals to 3/5. Sinus theta equals to 3/5. Here, but we actually have the trigonometric identity that cosine theta equals to the square root of 1 minus sinus square theta. That is to say, cosine theta equals to the square root of 1. Sinus theta equals to 3/5. Therefore, sinus square theta will be equal to 3/5 squared. That is, 3 squared is 9 and 5 squared is 25. So here we will multiply 1 by 25 and then we'll divide by 1 by 25 in order to have a common factor with this expression. And we'll get that cosine theta equals to the square root of 25 minus 9 over 25. So we found out actually that sinus theta equals to the square root of 25 minus 9 is 16 over 25. So sinus theta equals to the square root of 16 is 4 and the square root of 25 is 5. So in conclusion, we found out that sinus theta equals to 4/5. So in the next step we will implement the law of cosines in our triangle ABC. I repeat quickly on the law of cosines. The law of cosines is true in any triangle, so if we have a triangle ABC that could be any triangle, this is triangle ABC. The angle between side AB and side AC is theta. The length of side AB is equal to A units. Side AC equals to B units in its length. And side BC equals to C units in its length. This is the law of cosines. So according to the law of cosine, we get that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. Okay? We will implement the law of cosines in our triangle ABC. So in our triangle ABC, we will get that cosine theta, according to the law of cosines, cosine theta will be equal to 5 times 6, 5 squared. Cosine theta equals to 5 squared. That is, AB squared is 5 squared, that is 25, plus 6 squared, that is 36, minus AC squared over 2 times 5 times 6. Okay? We have already found out that cosine theta equals to 3/5. We have already found out that cosine theta equals to 4/5. Yeah. We have already found out that cosine theta equals to 4/5. So we can substitute cosine theta by 4/5, and it is equal to 25 plus 36 is 61 minus AC squared over 5 times 6 is 30 and 30 times 2 is 60. Here we'll multiply this equation by 60 and we get that 60 times 4 over 5 equals to 61 minus AC squared. 60 over 5 is 12, so we have 12 times 4, that is equal to 61 minus AC squared. 12 times 2 is 48, so 48 equals to 61 minus AC squared. Here we'll subtract 48 from this equation and add simultaneously AC squared, and we'll get that AC squared equals to 61 minus 48 is 13, so AC squared equals to 13. We'll take out of this equation and we'll get that AC equals to the square root of 13 units. AC equals to the square root of 13 units. So here you can write down that AC equals to the square root of 13 units. In the next step I will present to you a new formula that is about a circle that blocks triangle. The radius of the circle that blocks triangle, like in our drawing. The radius of a circle that blocks triangle, that is to say capital R, it is equal to the multiplication of the sides of the triangle that has been blocked by the circle. So the triangle that is inscribed by the circle, in this case it is AB times AC times BC, AB times AC times BC, over 4 times the area of the triangle that is inscribed by the circle. That is to say, in this case, it is triangle ABC. So the new formula is that the radius of the circle that blocks the triangle, it is equal to the multiplication of all the sides by each other of the circle that is inscribed by the circle, of the triangle that is inscribed by the circle, over 4 times the area of the same triangle that is inscribed by the circle. So in our case, we get that R equals to AB. AB equals to 5 units, times AC is equals to square root of 13 units, times BC, BC equals to 6 units, over 4 times the area of triangle ABC. It has been given to us that the area of triangle ABC equals to 9 units, so it is 4 times 9. So in conclusion, we will find out that R equals to 5 times 6 is 30, so it is 30 times square root of 13, over 4 times 9 is 36. So R equals to, here we will divide both the numerator and the denominator on this side of the equation by 6. 30 over 6 is 5. So it is 5 times square root of 13 over 36 over 6 is 6. So in conclusion, we found out that the radius that we are looking for of the circle that blocks triangle ABC, it is equal to either 5 times square root of 13 over 6 units, so in terms of numbers it is equal to 3.00 units. That is a little bit greater than 3 units. Okay, so we finished with the third method. The next step I will summarize the lecture. We'll start with the first question, of course. So in the first question, we have this circle. We have the big circle. Triangle ABC is inscribed by the big circle, and inside triangle ABC we have a small circle, so the small circle is inscribed by triangle ABC, and triangle ABC itself is inscribed by the big circle. We know that the radius of the big circle equals to 13 units and the radius of the small circle equals to 4 units, And we also know that AB is the diameter of the big circle, and we want to find out the blue area. So first of all, we define the center of this circle as point O. We define the point of tendency of tangent AC with this small circle as N. We define the point of tendency of tangent BC with this small circle as M. And we define the point of tendency of tangent AB with this small circle as L. Then we join points O and N together by a straight line. What is the definition of line segment ON? O is the center of the small circle and N is the point of the small circle itself. This is exactly the definition of a radius. That is to say, ON equals to the radius of the small circle that is R, and we know that R equals to 4 units. So here we have the radius of this circle, and we have rule number 1 that states that a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So we have here the radius ON that is drawn to the point of tendency. That is to say, it is drawn to point N, that is the point of tendency of tangent AC with this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NO. So if AC is perpendicular to NO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule number 1. And then we join points O and M together by a straight line. O is the center of the small circle, M is the point of the small circle itself. Therefore, OM is the radius of the small circle that is equal to 4 units. And again, we have the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent CB with this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So if CB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle will be also equal to 90 degrees according to rule number 1. Then I also presented to you a rule that states that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. Here, peripheral angle ACB, this angle ACB rests on AB, that is the diameter of the big circle. Therefore, according to the rule that I mentioned, the peripheral angle ACB equals to 90 degrees. So this angle also equals to 90 degrees. So in quadrilateral OMCN, we have 1, 2, 3 right angles. Okay? I repeat again. In quadrilateral ONCM, we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is angle MON. In total, those 4 angles must be equal in total to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation and found out that the missing angle MON, equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So actually we found out that inside quadrilateral MONC we have 4 right angles, and any quadrilateral that those 4 right angles must be at least a rectangle if not a square. So we will relate to quadrilateral ONCM as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle OMCN are equal to each other. It means that ON must be equal to CM. ON must be equal to CM. ON must be equal to CM. But we have already found out that ON equals to 4. This is the radius of the circle. So from this equation 4 equals to ON equals to CM, we will derive that CM is also equals to 4 units. Here, CM is also equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we will get that OM equals to NC in quadrilateral OCMN. OM equals to NC. OM equals to NC. But we have already found out that OM equals to 4 units. It is the radius of the small circle. OM equals to 4. So from this equation 4 equals to OM equals to NC, we will derive that NC is also equals to 4 units. Here NC is also equals to 4 units, so all the sides of quadrilateral OMCN are equal to each other, therefore quadrilateral OMCN, it is not a rectangle but a square. Okay? Then we defined AC as A. We defined side CB of triangle ABC as B, and we defined side AB, that is the diameter of the circle, the big circle, as C. Okay? So what is the length of line segment AN? From the drawing it is very easy to see that AN equals to AC minus NC. AN equals to CA minus NC. Okay, so AN equals to CA. CA is A according to our definition, and NC is 4. So in conclusion, we found out that AN equals to A minus 4. Okay, then we found out the length of line segment MB. From the drawing it is very easy to see that MB equals to CB minus CM. CB minus CM equals to MB. MB equals to CB minus CM, so MB equals to CB, that is B. According to our definition, CB is B. Minus CM, that is 4 units. CM is 4 units. So in conclusion, we found out that MB equals to B minus 4. Here MB equals to B minus 4 and AN equals to A minus 4. Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common extreme point to a circle are equal. The lengths of two tangents from a common extreme point to a circle are equal. So if we focus on the common extreme point, point A, from the common extreme point, point A, we have two tangents to the circle, tangent AL and tangent AN. And according to rule number 2, they must be equal to each other. So if point A, AN must be equal to AN according to the rule that I mentioned. Okay, so AL must be equal to AN. Okay, AN must be equal to AN, but we have already found out that AN equals to A minus 4. So here AN equals to A minus 4, and from this equation AL equals to AN equals to A minus 4, we will derive that AL is also equals to A minus 4. Here AL is also equals to A minus 4. Then we focus on the common extreme point, point B. From the common extreme point, point B, we have two tangents to this small circle. We have tangent BL and tangent BM, and according to the rule that I mentioned just a minute ago, the lengths of those two tangents must be equal to each other. That is to say, BL equals to BM according to the rule that I mentioned. Here, BL must be equal to BM according to rule number 2. But we've already found out that BM equals to B minus 4. So we can write here that BM equals to B minus 4. And from this equation, BL equals to BM equals to B minus 4, we'll derive that BL is also equals to B minus 4. Here BL is also equals to B minus 4. And then we know that AB is the diameter of this big circle, and the diameter is always twice as long as the radius. So if the radius of the big circle is r, then the diameter AB will be equal to 2r. But we know that the radius of the circle equals to 13. So AB is 2r, that is to say AB equals to 2 times 13, that is 26. So we found out the diameter of this big circle equals to 26 units, that is to say C also equals to AB is also equals to 26 units. Okay, so from one side AB, that is the diameter of the big circle, equals to 26 units. From the other side AB, from the drawing you can see that AB equals to AL plus LB. Again, AB equals to AL plus LB. Repeat again, AB that is equal to 26 equals to AL plus LB. Okay, but AL equals to A minus 4. LB equals to B minus 4. Here, AN equals to A minus 4 and NB equals to B minus 4. So the diameter of AB that is equal to 26 in conclusion equals to A minus 4 plus B minus 4. So 26 equals to A plus B, minus 4 plus minus 4 is minus 8. So according to equation number 1, the diameter AB equals to 26, that is equal to A plus B minus 8. We added 8 to this equation, equation number 1, and found out that A plus B equals to 26 plus 8, that is 34. So according to equation number 1, A plus B equals to 34. We squared this equation, equation number 1, and we found out that AB squared equals to 34 square. AB squared equals to 34 square. So A plus B squared equals to 34 square, and 34 square is 1156. Okay, 34 square is 1156. Then we open the brackets on this side of equation number 1, and we found out that A plus B square equals to A square plus B square plus 2 times AB, and it is equal to 1156. Then we focus on triangle ABC. Triangle ABC is right triangle because of the fact that angle ACB equals to 90 degrees. So we can implement the law for Pythagoras theorem in triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, therefore the square of the hypotenuse AB square must be equal to AC square plus CB square. So according to equation number 2, and Pythagoras theorem, in triangle ABC, AB square equals to AC square plus CB square. Here AB equals to C according to our definition, so AB square is C square. AC equals to A according to our definition, so AC square is A square, plus BC square. BC equals to B according to our definition, so BC square is B square. So in conclusion, we found out that according to equation number 2, C square equals to A square plus B square. So we've already found out that the hypotenuse AB equals to C according to our definition, and the hypotenuse AB that is equal to C, it is equal to 26 units, so we can substitute C by 26. So if C equals to 26, then C square equals to 26 square, that is equal to A square plus B square. So according to equation number 2, we found out that A square plus B square equals to 26 square. That is to say, according to equation number 2, A square plus B square equals to 26 square, that is 676. And because of the fact that A square plus B square equals to 676, it means that we can substitute, according to equation number 2, we can substitute A square plus B square in equation number 1 by 676. We did it, and we got that according to equation number 1, A square plus B square is 676, plus 2AB equals to 1156. We subtracted 676 from this equation, equation number 1, and found out that 2 times AB equals to 1156 minus 676, and 1156 minus 676 is 480. So conclusion, we found out that 2 times AB equals to 480. We divided this equation, equation number 1 by 2, and we found out that A times B equals to 480 over 2. 480 over 2 is 240. So we found out that according to equation number 2, A times B equals to 240. We divided this equation, equation number 1 by 2, and we found out that AB over 2 equals to 240 over 2 is 120. So according to equation number 1, AB over 2 equals to 120. Then what is the area of the blue shape? From the drawing it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. I'll repeat again, the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. And the area of triangle ABC equals to the base of the triangle that is AC times the height that is CB over 2. Again, the area of triangle ABC equals to the base of the triangle that is AC times the height that is CB over 2. Minus the area of the small circle, the area of the small circle equals to pi r square when r equals to 4 units. So the area of the blue shape AC is A and BC is B. So AC times CB over 2 is A times B over 2. Minus 16 pi, because R equals to 4, so R squared is 4 squared, that is 16. So in conclusion, the area of the small circle equals to pi R squared, that is 16 pi. Okay? And we have already found out that AB over 2 is 120, so we can substitute AB over 2 here by 120. We did it, and we got the area of the blue shape. In conclusion, it is equal to either 120 minus 16 pi square units, so in terms of numbers, it is equal to 69.73 square units. I'll repeat again, the area of the blue shape here equals to either 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. Okay, so we finished with the first question. Then I presented to you the second question, and we solved the second question in 3 different methods. So we start with the first method. In the drawing we have this circle, and we know that the area inside this circle there is triangle ABC that is inscribed by the circle, and the area of this triangle ABC equals to 9 square units. And we also know that side AB of triangle ABC is 5 units, side BC of triangle ABC is 6 units. And we want to find out the area of the radius of the circle that blocks triangle ABC. Okay? So first of all, we made the construction. We actually, from point A, we draw perpendicular on BC, so this angle equals to 90 degrees, and this angle also equals to 90 degrees. According to our construction, we define the touching point of the perpendicular from point A and BC as D. Okay? So we actually know that the area of triangle ABC equals to 9 square units. Here the area of triangle ABC equals to 9 square units. And the area of any triangle equals to the base of the triangle that is BC times the height that is AD over 2. BC equals to 6 units according to what is given as the question, times AD over 2. 6 over 2 is 3. So in conclusion, we found out that time equals to 3 times AD. We divided this equation number 1 by 3, and we found out that AD equals to 3 units. Here AD equals to 3 units. Then we focused on the right triangle, triangle ABD. In this right triangle, triangle ABD, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to AD square plus BD square. AB square equals to AD square plus BD square. AB equals to 5, so AB square is 5 square, that is 25. Plus AD square, AD equals to 3, so AD square is 3 square, that is 9. Plus BD square. Here we subtracted 9 from this equation, equation number 2, and we found out that 25 minus 9 is 16, so 16 equals to BD square. We took out of this equation, equation number 2, and we found out that BD equals to the square root of 16, that is 4. So here BD equals to 4 units. Then we focused, and what is the value of DC? From the drawing it is very easy to see that DC equals to BC minus DB. Here DC equals to BC minus DB. That is to say DC equals to BC, that is 6 units, minus BD, that is 4. So in conclusion, we found out that DC equals to 6 minus 4, that is 2. So here, line 7, DC equals to 2 units. Then we focus on the right triangle ADC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to AD square plus DC square. AC square equals to AD square. AD is 3, so AD square is 3 square, that is 9. Plus DC square. DC is 2, so DC square is 2 square, that is 4. So AC square equals to 9 plus 4, that is 13. AC square equals to 13. We took out of this equation, we found out that AC equals to the square root of 13 units. Here AC equals to the square root of 13 units. Then we actually, from point, we define the center of this circle as point O, and we joined points A and O together by a straight line, and then we extended the straight line AO by a straight line until it touches the circle at point E. Point E is the touching point of the extended line segment AO and the circle. So line segment AE passes through the center of the circle, that is point O, and any chord that passes through the center of the circle, it is defined as the diameter of the circle. So AE is the diameter of the circle, that is to say it is equal to 2 times the radius of the circle, that is 2 times capital R. Okay? Then we join points E and B together by a straight line. So here, angle ABE rests on AE, that is the diameter of this circle, therefore it is equal to 90 degrees. Why? Because any peripheral angle that rests on the diameter of a circle must be equal to 90 degrees, therefore angle ABE equals to 90 degrees. And we have also another rule that chords, peripheral angles that rest on the same chords are equal to each other. If those two angles, they are both rest on chord AB, therefore they are equal to each other. So here, angle ACB equals to angle AEB, because those are two peripheral angles that rest on the same chord, chord AB, therefore they are equal to each other. Then we define angle AEB as theta. Here angle AEB equals to theta. So from this equation, angle ACB equals to angle AB equals to theta, we derive that angle ACB is also equals to theta. Here angle ACB, this angle also equals to theta. So in this triangle ADC, this angle equals to theta. This angle equals to 90 degrees, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this triangle to 180 degrees. For the same reason, this angle also equals to 90 degrees minus theta. Then we prove that those two right triangles are similar to each other. Why they are similar to each other? First of all, those two angles are equal to each other, they are both equal to 90 degrees minus theta. Those two angles are also equal to each other, they are both equal to theta. Those two angles are also equal to each other, they are both equal to 90 degrees. So we found out that all the angles of triangle ABE can go into all the angles of triangle ADC, therefore triangle AEB is similar to triangle ADC according to angle similarity rule. Okay? And from the fact that those two right triangles are similar to each other, we will derive that AB over AD equals to AE over AC. Again, AB over AD equals to AE over AC. AB equals to 5, AD equals to 3. AE is the diameter of the circle, that is 2R, over AC is square root of 15. Here we multiply this equation by square root of 15 and found out that 5 times square root of 15 over 3 equals to 2R. We divided this equation number 3 by 2 and found out that the radius of this circle, the radius that we are looking for, it is equal to either 5 times square root of 13 over 6 units, or in terms of numbers, it is a little bit greater than 3 units. So we finished here with the first method. Then I presented to you how to find out the radius of the circle, the radius of this circle that blocks triangle ABC according to the second method. We relied on the things that we already found out that in the first method. Here from point A we draw perpendicular on BC and we define the touching point of the perpendicular from A and BC as D. We already found out that AD equals to 3 units, CD equals to 2 units, and BD equals to 4 units. Then we extended the perpendicular AD by a straight line until it touches the circle at point E. Point E is the touching point of the extended line segment AD in the circle. Then I presented to you rule number 1. According to rule number 1, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We actually can implement rule number 1 in our drawing, because in our drawing we have chord AE that intersects with chord BC at point D. Therefore, according to rule number 1, we get that BD times DC equals to AE equals to AD times DE. Here, BD times DC equals to AD times DE according to rule number 1. BD equals to 4, DC equals to 2, AD equals to 3, and DE is the missing line segment. So 4 times 2 is 8, 8 equals to 3 times DE. We divided this equation by 3 and we found out that DE, the missing line segment DE, here equals to 8 thirds, 8 over 3 units. Then I presented to you rule number 2, and we implemented rule number 2 in our drawing. According to rule number 2, if chord AB intersects with chord CD at 90 degrees, that is to say in the intersection point, they create 90 degrees with each other. Here. Then the following equation is true, that 4 times R squared equals to A squared plus B squared plus C squared plus D squared. Again, 4 times R squared equals to A squared plus B squared plus C squared plus D squared. So actually can implement rule number 2 in our drawing, because in our drawing we have chord AE that intersects with chord BC at 90 degrees. Therefore, according to rule number 2, we get that 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. So here, 4 times R squared equals to DB squared plus DC squared plus AD squared plus DE squared. So 4 times A squared equals to DB squared, DB is 4, so DB squared is 4 squared, that is 16, plus DC squared, DC is 3, so DC squared is 3 squared, that is 9, plus AD squared. Here, actually AD, it is equals to 3, so AD squared is 3 squared, that is 9, plus DE squared. DE equals to 8 over 3, so DE squared is 8 over 3 squared. 8 over 3 squared is 8 squared, that is 64, over 3 squared, that is 9. So in conclusion, we found out that 4R squared equals to 16 plus 4, that is 20, 20 plus 9 is 29, so 29 plus 64 over 9 equals to, here we multiplied 29 by 9, and then we divided by 9 in order to obtain a common factor with this expression. 29 times 9 is 261, plus 64 over 9. 261 plus 64 is 325 over 9. So in conclusion, we found out that 4R squared equals to 425 over 9. We divided this equation by 4 and found out that R squared equals to 325 over 9 times 4 is 36. So we substituted 325 by 25 times 15 and found out that R squared equals to 25 times 13 over 36. So we took the root out of this equation and we found out that R equals to the square root of 35, square root of 25 is 5, over square root of 36 is 6, times square root of 13. So in conclusion, we found out that R, the radius of this circle that we are looking for, it is equal to either 3 over 6 times square root of 13 units, so in terms of numbers, it is a little bit greater than 3 units. We finished with the second method. In the next step I present to you how we found out the radius of this circle that says blocks triangle ABC according to the third method. Actually, according to the third method, we define angle ABC as theta, and we have a special formula to find out the area of any triangle. If this is triangle ABC, that could be any triangle. The angle between side AB and side AC is theta. Side AB equals to units in its length, side AC equals to B units in its length. Then the area of this triangle, triangle ABC, equals to A times B times sinus theta over 2. Again, the area of this triangle, triangle ABC, equals to A times B times sinus theta over 2. Okay, so we calculated the area of our triangle ABC, according to this formula, and according to this formula, the area of this triangle ABC will be equal to 5 times 6 times sinus theta over 2. The area of triangle ABC equals to 5 times 6 times sinus theta over 2, but we know that the area of triangle ABC equals to 9 square units. So we can write here that 9 equals to 5 times 6 times sinus theta over 2. Here 5 times 6 is 30 and 30 over 2 is 15. So in conclusion, we found out that 9 equals to 15 times sinus theta. We divided this equation number 1 by 3. And we got that 9 over 3 is 3 and 15 over 3 is 5. So in conclusion, we found out that 5 times sinus theta equals to 3. We divided this equation by 5 and we found out that sinus theta equals to 3/5. Then we have the trigonometric identity that cosine theta equals to the square root of 1 minus sinus squared theta. And here we know that sinus theta equals to 3/5. If sinus theta equals to 3/5, it means that sinus squared theta will be equal to 3/5 squared, that is to say it is equal to 3 squared, that is 9 over 5 squared, that is 25. So in conclusion, we found out that cosine theta equals to the square root of 1 minus 9 over 25. Here we multiplied 1 by 25 and then we divided by 25 in order to overcome the factor of this expression. And we found out that cosine theta equals to 25 minus 9 over 25. 25 minus 9 is 16. So it is 16 over 25. And the square root of 16 is 4. And the square root of 25 is 5. So in conclusion, we found out that cosine theta equals to 4/5. Okay, cosine theta equals to 4/5. Then we actually implemented the law of cosines in our triangle ABC. But first of all, I presented to you the law of cosines. What is the law of cosines? The law of cosines is true in any triangle. So if we have this triangle ABC that could be any triangle, side AB equals to A units, side AC equals to B units, side BC equals to C units in length, and the angle between side AB and side AC is theta. Then according to the law of cosines, cosine theta equals to A squared plus B squared minus C squared over 2 times AB. Okay, so we implemented the law of cosines in our triangle ABC. According to the law of cosines, we get that cosine theta will be equal to 5 squared plus 6 squared minus AC squared over 2 times 5 times 6. Again, cosine theta equals to 5 squared, that is 25, plus 6 squared, that is 36, minus AC squared over 2 times 5 times 6. We have already found out that cosine theta equals to 4/5. So we can substitute cosine theta by 4/5. When we found out that 4/5 equals to 25 plus 36 is 61, minus AC squared equals to 5 times 6 is 30, and 30 times 2 is 60. So in conclusion, we found out that 4/5 equals to 61 minus AC squared over 60. We multiplied this equation by 60 and found out that here 60 times 4/5 equals to 61 minus AC squared. Okay, so here 60 over 5 is 12. So in this side of the equation we have 12 times 4, that is equal to 61 minus AC squared. So here 12 times 4 is 48, is equal to 48 equals to 61 minus AC squared. Here we added AC squared to this equation and subtracted 48, and we found out that AC squared equals to 61 minus 48 is 13. So AC squared equals to 13. We took out of this equation and we found out that AC equals to the square root of 13 units. Here AC equals to the square root of 13 units. Then I presented to you a new formula that gives us the radius of any circle that blocks triangle, like in our drawing. The radius of this circle that blocks triangle ABC will be equal to the multiplication of the sides of the triangle that is blocked by the circle. In this case, this triangle ABC, and the multiplication of its sides is AB times AC times BC, AB times AC times BC, over 4 times the area of the triangle that is blocked by the circle. In this case, this is triangle ABC, over 4 times the area of triangle ABC. So the radius of this circle equals to the multiplication of the sides of the triangle over 4 times the area of this triangle, triangle ABC. AB equals to 5, AC equals to 13 units, and BC equals to 6. Over 4 times the area of triangle ABC is 9. So here 5 times 6 is 30. So it is 30 times 4 to 13, and 4 times 9 is 36. So in conclusion, found out that R equals to 30 over 36 times 4 to 13. We divided both the numerator and the denominator of this on this side of the equation by 6. 30 over 6 is 5, and 36 over 6 is 6. So in conclusion, found out that the radius of this circle that blocks triangle ABC equals to either 5 times 4 to 13 over 6 units, or in terms of numbers, it is a little bit greater than 3 units. Okay, thank you very much.